Hey guys, it's Paulo Haddad here, and in this video we are going to see the reports we have under the show menu for power. So back to our DSS here in my computer. This is the file that we have been working in this tutorial. So let's solve it first. So Control A, Control D. So as you can see in the summary here, we have the status solved. Okay, with that said, we can go to show menu and we can go to powers. Here we have powers KVA, powers MVA, powers KVA elements, and powers MVA elements. So I'm gonna just look at the KVA reports, basically because MVA is the same thing, but in MVA, not in KVA, right? So let's go to powers KVA first. So in this report, what we have the symmetrical component powers by element. So for instance, we have here the symmetrical components for our circuit element, and for each element we have powers in the first and the second terminal, right? It's interesting to see in the circuit element is that for the second terminal the powers are 0, and it's because the second terminal of the circuit element by default is connected to the node 0. Therefore, the power 0 because the voltage in node 0, which is our reference, is 0, okay? But for instance, here for a transformer, we have our symmetrical components for the power entering in the terminal 1 and the power entering in the terminal 2. Like I said before, you see that it's negative when it's entering in the terminal 2, because actually the power is getting out of terminal 2. So for OpenDSS, power is positive when enters in the terminal of the elements. So if you have this transformer, we see that in terminal 1 it's positive because it's entering in the first terminal of the transformer. However, in the second terminal it's getting out of the terminal. Therefore, you're gonna see a negative sign. Okay, so you have we have here also for lines. So the same thing. And finally, for our loads, just one terminal because they are PC elements here, so just one terminal. Okay, interesting. So what we have here, P1, Q1, which is the positive component. We have the negative component and the 0 component as well. And we also have an interesting thing here for our line. Let's say this line here. We have power normal, active reactive, and active reactive power, emergence power. What is this actually? So I will show you how OpenDSS calculates this power normal here for this line, and I'll give you just an idea. So let me open my command prompt. I will open Python, and I'm gonna do some calculations here. So first thing I'm gonna do, I'm gonna go show currents elements, and the line we want is 650, this line here. So let's get the max current, this guy. This is the max for the first terminal, and I'm gonna say here Emax equals this number. Another thing that I wanna get here, I can use the format dit for a line. So PD here, and then line, and then I select the line I want, this line, and then format dit, and then I can see that the normal amps is 400. Okay, 400. So we will go here and norm, I'll say 400. So basically what OpenDSS is doing, OpenDSS is doing to calculate those numbers the following. If the max current is greater than the norm amps. In our case, it is. OpenDSS calculates a factor, which is Emax minus En divided by Emax. This is a factor that OpenDSS calculates, 0.32, and OpenDSS will basically let's see if there is component. We'll use actually not the component, but OpenDSS is going to use the total power of that line. So let me go ahead and show you that just to finish this thought. So powers element, and I have my line here. I will explain in a second this file, but just to go ahead and finish what I'm trying to say. So this is the total power for that first terminal of that line. So let me go ahead in my Python and say that the total power, let's say P total, is this number. Okay. Why I opened the elements? Because the first one, it's the symmetrical components, not the total three-phase power, right? So that's why I opened the other one to get the right number. So the number you see here is basically this factor times P total. So as you can see, it's the same number, 1100 something. So it's the same thing. However, one important aspect here to show you is that if your Emax is less than this 400, OpenDSS just say that is 0. So the speed normal here basically tries to show you an idea of how much power you have over the nominal, right? For the emergence, you basically, if I go back here and get the emergence amps is 600, it will just have a number different from 0 there if my max current were greater than 600, right? So well, this is what OpenDSS is doing, just to let you know. Okay. All right, so close this file back here. So that's what we have, just to let you know that in the end of this power file, we have the losses. So those numbers are basically what we should have here in the summary as well, okay? Those are results for a snapshot simulation, or the last power flow or simulation that OpenDSS has performed. Let's go to the second file, element. Basically, remember that when you are talking about element file, result file, it's basically divided into power delivery elements and as well as power conversion elements, right? Here we can see that we have our circuit element. Like I said before, the first terminal we have voltage different from 0, therefore have powers because we have currents. However, here, even though we have currents coming into this node, since this node is the reference, which node 0, the voltage is 0, therefore there is no power. Okay. We have the transformer. Interesting to see that transformer we have node 0. I believe it's because Y grounded connection. I should double check later if a delta connection will also have the node 0. So if you can, please check that and leave in the comment section below. That will help us a lot. Yeah, we have transformers, and then we have our lines. So basically what this file is showing us is the first bus or first terminal, the second terminal, the power, let's say here, active power, reactive power, apparent power, and power factor. We have for phase 1 or node 1, node 2, node 3, and the Toro as well. Okay, very interesting to see that. So that's all I have to show you. Actually, finally, just to let you know that we have also losses in this file, in the end of this file, and that's all we have to show you regarding the show me new for powers. I hope you are enjoying this content that I'm doing in English. If you support it, don't forget to give me a thumbs up. If you are new to my channel, please subscribe and also hit the bell button so you'll be able to get my notification when I upload any new video. I hope you are enjoying that, and I hope to see you in the next video.